Good day, everybody. Today we're going to be chatting about my new custom-made fan controller and LED light controller for my new Lulzbot Mini 2. Just replaced my Mini 1, which I'm selling, by the way. Just before we get into details, some sort of props. I want to shout out to MakerWiz for I picked up the Mini from them in Canada here, and also shout out to buyapie.ca, running OctoPrint on Pi, the newest 4B, version 4B there, so very fast startup. I'm very impressed. I don't like to wait for my stuff to start up. Anyway, getting into the detail of this build, this controller is custom built. It's got it's based on a Arduino Nano that's running inside the case of the Mini 2. It's got one is fan and temperature monitoring. So one of the key reasons why I wanted to do this was even though the Lulzbot Mini 2 is much more quiet than the Mini 1, the case fan on the side here is still quite noisy. So on my Mini 1 I had built a similar thing, and you'll see a link in my blog for that, to replace the fan with a Noctua fan, and it greatly reduced the machine noise, as does this. So right now, as you can hear, the fan is running in the case, and it's running at a low speed, and you can barely hear it. And I've actually posted some numbers, sound decibel measurements, to show just how quiet it is compared to even the Mini 2 case fan. I think the stock fan runs about 82 to 85 decibels, and this hums along at about 55, which is about speech level, the speech level I'm speaking right now. So anyway, what the controller does, it's based on, again, an Arduino microcontroller. This is a next-gen HMI display, 2.4 inch, and again in my blog you'll see lots of details about that. The idea is it measures the temperature of the Einsy, which is the board inside the Mini, using an LM35 temperature chip, and then also I have one measuring the temperature of the OctoPi, or the Raspberry Pi CPU, and you can see that here. It's just got the LM35 is tied down to the heatsink using a custom printed bracket. I didn't want to glue it because oftentimes I have to remove the Pi and do work, so I wanted to make it easily removable. And of course it's got some other things like LED control, so I'll demonstrate that in a second. This measures the fan RPM, so it's currently set at about 32% of max. So I can monitor as a print job happens, and it dynamically measures the driver on the Einsy board, mainly the actual the Y driver chip, because the Z, as you know, barely moves up and down, but you often have the motion of X and Y, and they generally both have the same temperature. So I'm monitoring only one of them, and then I use that value to change the fan speed. It also has the ability, in case for whatever reason I want to just, I think things are going to get hot, I can just touch the screen. You can hear that now. Puts the fan up at high, about 2200 RPMs, and I can then set it back to automatic mode. A little bit of a glitch there, displaying the temperature, so I've got to fix that. Also the LED, so it has multiple states. So again, same thing, touch screen will turn the lights on and off, so I'll bear with me with my camera here. So it sets the LEDs in high. I can reposition these LEDs wherever I want to monitor the print job, especially if I'm doing any kind of recording. So I've got, again, 2 LEDs. So we can go high, medium setting, a little bit dimmer, and then low setting, and then off. So that's pretty much it. Again, I'm going to do a full write-up on my blog. You'll see a link at the bottom of my YouTube settings here, but thank you for watching.